Okay, today's video is going through our study guide for Chapter 13 rather quickly. So if you have any questions about anything, please don't hesitate to email me or come see me in the morning. Okay, so to start off with, our calculator portion, which is for some odd reason, starts at number 11. We have to sketch each angle in standard position. So actually that's not what I wanted. I want a ray, and it doesn't really matter what color you do, 140 degrees. So I'm looking and trying to remember on my unit circle what quadrant it's in. This is 180. Halfway between is 135, so just a little bit past that would be something of that sort. So you need to draw a ray in the quadrant, the terminal side of the quadrant, and then starting at that positive x-axis, drawing an arrow in the direction that we go, and labeling it as 140 degrees. And I'm having there we go, 140 degrees. Okay. Um, Negative 290. Okay. In a similar fashion. Okay. Where's negative 290? Well, where's positive 290? Positive 270 is down here. So if I kept going a little bit further, that would be negative 290. And we've talked about how you can flip it. So that means that I'm going to be drawing something just a little bit past 270. And what's important about it, again, is that you start that direction arrow at the positive x-axis and show me that we're going in a clockwise direction, and then label it negative 290 degrees. Okay, so moving on. Give an angle between 0 and 360 that is coterminal with each angle. So when you subtract, okay, anytime you're doing coterminals, you're basically subtracting 360 from that number. So 1000 minus 360 is going to be 640, which is not a number between 0 and 360. So then you subtract 360 again, and when you do that, you're going to end up with 280. And that's 280 degrees, and that is an answer between 0 and 360. Okay, if that angle is negative, then to get between 0 and 360, I'm going to add 360 to it. And so negative 48 plus 360 is going to give me an angle that is 312 degrees. Okay, moving along. Convert each degree measure to radians and each radian measure to degrees. So the conversion factor that you want to remember is on the left side of your circle, to remember that pi is equal to 180 degrees. I'm going to scoot up a little bit while I do that. Okay, so if I have degrees, I want to get rid of the degrees, so I'm multiplying this by pi over, well, I already did that. Try that one more time. Pi over 180 degrees. Okay, my zeros cancel, so that's 5 pi over 18. If you have any question about how to reduce that, this is on the calculator portion, so make sure you can put 5 or 50 over 18 as a fraction and reduce it. You don't need to worry about the pi, and just put it in your answers. Negative pi over 9, I'm going to go over here because it's kind of tight. So negative pi over 9, I'm going to multiply that by 180 degrees over pi, because I want my pi's to cancel. I want to have degrees when I finish. 9 goes into 180 20 times, so I know my answer is going to be 20 degrees. Keep in mind I had a negative to start with. You're just going to carry that over to your answer. Okay, so negative pi over 9 radians is the same thing as negative 20 degrees. I can't change the angle. Okay, again, I have degrees, so if I have degrees, I want to go 2 radians, and so radians goes on top, and 80 over 180 is going to simplify on your calculator to to 4 pi over 9. 80 over 180 will simplify to 4/9 on your calculator. You carry the negative over and you keep the pi in your answer. Okay, moving along to this last one. Again, I'm going to go over because it's kind of tight. So that's 3 pi over 10 times 180 over pi. My pi's cancel. Okay, I have a 0 on the top and the bottom. 3 times 18 is 54 degrees. So that's what we got. Okay, to move again, moving quickly. Solve each equation using a graphing calculator. Find all solutions between 0 and 2 pi. So that's a clue that you need to make sure your calculator, your graphing calculator is in radians. Okay, round to the nearest hundredth. There's two zeros and 100, so you make sure you have two places. So I went ahead and put these numbers in the calculator. All right, this is the first one, which says 4 times the sine of x. It said equals -1 on your study guide. If you look at that, it says equals -1. But we are using the zero method, and that means that we're going to set it equal to 0. So I have to add the 1 to both sides. And when I do that, it looks like this. And now I'm looking for the zeros of my function. And the zeros are where it crosses the x-axis. I only need them between 0 and 2 pi, which is about 6.28. But after you've graphed your function, if you want to know what that looks like, okay, I can't hit tab right now. I'm going to take that off. So if it'll let me hit tab so I can show you. Hit the tab button and the up arrow, and you can see that that is the function that we have graphed. So from here, I hit Menu, Analyze Graph, 0, and I'm going on. I can only do one zero at a time. So here's one of my zeros. It's going to be 3.39, but I have to go find the other one. So I hit Menu, Analyze. I want the 0. I go on the left side of the 0 and then the right side of the 0 that I want. And both of those numbers are less than 6.28, which is what we discussed was between 0 and 2 pi. So for this first one, my answer will be x equals 3.39, and the other one is 6.03. All right, let's look at the next one on our graph. It's 5 times the cosine of 2x minus 3, because I've got to make it set it equal to 0. So when I did that, that's on the next page for me, 1.2. So I took the minus 3 to the other side, 5 times the cosine of 2x minus 3. And now I need all of these zeros. So I'm going to hit Menu, Analyze, 0. That one close is that number. Menu, Analyze, 0. Go on the next 0 that I have, which is 2.68. Menu, Analyze, 0. Alright, and notice again that I'm only doing one 0 at a time, y'all. And Menu, Analyze, 0. This last one is at 5.82. Put it up here so we can see them. Now, if you were to do another one, y'all, Analyze, 0, because you're like, I'm not really sure. Okay, that is 6.75. And that is larger than 6.28. So that's not one of the answers that you're going to give me. So what are you going to write in the answer blank? You're going to write down that x equals, we had 0.46, we had 2.68, we had 3.61, and we had 5.82. Now, we've talked about this several times. I don't know how many of y'all can get this, but notice that there were only 2 in between here. And that 2x meant we had 2 cycles in that same distance, so now we have twice as many, which is 4. Okay, find the length of s to the nearest tenth. S is my arc length, so it's asking me for this length right here. So you do need to know that formula, S equals R theta. And that means that R is my radius, which is 9 inches. Theta is my angle in radians, which is 11 pi over 6. I'm going to simplify that before I multiply. 3 goes into both of those numbers. So that gives me 33 pi over 6 inches. And you're going to put that in your calculator so that you can round that to the nearest tenth, because that's what the directions say right here. Round to the nearest tenth. And so that's going to be 51.8 inches. And please make sure you remember your units on that. Okay, non-calculator portion. You are using a unit circle. So what I will put next to it are the coordinates, and maybe I'll put the answers over to the left so you can check them as we go. Cosine of pi over 4, excuse me, pi over 4 it's in the first quadrant. The coordinates should be on your unit circle, square root of 2 over 2, comma square root of 2 over 2, which makes the cosine equal to that x value, so it is the square root of 2 over 2. Hmm. All right, the sine of negative pi over 3. Negative pi over 3 is in the fourth quadrant, and the coordinates at that point are 1/2, comma, negative square root of 3 over 2. Sine refers to the y coordinate, so this answer is negative square root of 3 over 2. Tangent of 3 pi over 4. 3 pi over 4 is in the second quadrant, and those coordinates are negative square root of 2 over 2. Okay, and if you wrote the tangent values on your circle, then you should have negative 1 out to the side, which makes the answer negative 1 because it's y over x. Okay, secant of 2 pi over 3. 2 pi over 3 is in the second quadrant, and that means that my x value is negative 1/2. My y value is the square root of 3 over 2. Secant is 1 over the cosine. This is my cosine value. So when I take the reciprocal of that, I'd be looking at my reciprocal chart if I wrote it at the bottom of my page. Otherwise, I have to know to take the reciprocal of negative 1/2, which is negative 2. All right, cosecant of pi. Pi is on the left side of your circle, has coordinates of negative 1, 0. Cosecant is 1 over the sine, and 1 over 0 is undefined. So my answer here will be undefined. All right, next says cotangent of pi over 2. Pi over 2 is straight up on your circle. The coordinates are 0, 1, and the tangent, if you wrote it right next to it, is undefined. So cotangent is 1 over the tangent, and if you remember 1 over that is 0. Or you can remember that cosine is cosine over sine, and 0 over 1 is 0. Tangent of 7 pi over 4. 7 pi over 4 is in the fourth quadrant, and the coordinates at that point are square root of 2 over 2, that's not negative, comma, negative square root of 2 over 2. And again, if you wrote your tangent values, you should have had a negative 1 out to the side, so the tangent is negative 1. You could also do y over x, and that's the same number over itself with a negative. Okay? Sine of 13 pi. We talked about our odd values of pi were on the left side of the circle, so those coordinates are negative 1, 0. Sine is the y, so that answer is 0. Cosine of negative 5 pi over 4. Negative 5 pi over 4 is, if 5 pi over 4 is in the third quadrant, so negative 5 pi over 4 is going to be in the second quadrant, which means my coordinates are negative square root of 2 over 2, square root of 2 over 2. So the cosine is my x coordinate, which is negative square root of 2 over 2. All right, and the last one of this bunch, cosecant of 5 pi over 6. 5 pi over 6 is in the second quadrant. It has coordinates of 1, nope, my bad, square root of 3 over 2, which is negative in the second quadrant, and 1/2. Cosecant is 1 over the sine, and 1 over 1/2 is 2. Okay? Write an equation for each translation. So when you were doing this, okay, remember that this was our function that incorporated any and all translations. We had a times the sine, or you could have cosine, okay? Sine of b times x minus h plus k, okay? This is our stretching. This is our vertical stretching, our horizontal stretching or compressing, shifting horizontally and shifting vertically. So y equals the sine of x shifted pi units to the right. that means h is equal to pi. So y equals the sine of x minus h. And if it's horizontal with the x, then you got to have parentheses. Silly me, that's supposed to be a pi. All right, and that would be your function because h is equal to pi. Cosine 10 units down, so that's of course going to be my k value, which would be outside. So y equals the cosine of x minus 10, not inside the parentheses. Okay, and the last one here, y equals the sine of 2x, 4 units to the left, pi over 4 units up. So this is my h, and this is my k. But keep in mind that when h, or when you have that in there, that 2 is outside. So it must be outside your parentheses. Sine of 2 times x to the left means it's the opposite. X plus 4, and then plus pi over 4. So that's pretty straightforward. Okay. Okay, to talk about the graphing. Graph 2 cycles of the following functions. Be sure to label each axis and asymptotes. So, funny, I've got two 14s there. All right, so to start off with, first thing you always want to do is make sure you know what the period is, okay? And remember y equals a times the sine of b, x minus h plus k. B affects our period, a is our amplitude. So my period is 2 pi over 4. So on my functions, I'm going to go quickly put a set of axes on here. Okay. And that makes my period equal to pi over 2. So I go out 4 tick marks and label that pi over 2. So you need to label that second tick mark, half of that. 1/2 times pi over 2 is pi over 4. So this is pi over 4, 1 pi over 4, 2 pi over 4. This is 3 pi over 4, and this is 4 pi over 4. But my period is just between 0 and pi over 2. So that's where I'm going to do one period to begin with. I know that my sine function starts at a 0, ends at a 0. Halfway between is a 0. Halfway between the first two, I have a max. Well, that means I'm going to go make that my max of 3 and negative 3. Halfway between my min is my negative 3. We have to do 2 cycles, so I have to repeat that. So I go start at a 0, ends at a 0, halfway between is a 0, halfway between the first two is a max, and halfway between the last two is a min. So then I'm going to do my best to connect them and make sure you put arrows because this function does continue on and on. Okay, so number 15, y equals negative 2 times the cosine. Again, got to find that period, which is 2 pi over b, which is 5. All right, I'm going to go put my axes on here. And I'm going to go out 4 tick marks and label it as 2 pi over 5. So 1, 2, 3, 4. This is 2 pi over 5. So halfway is 1 pi over 5. 1 pi, 2 pi, 3 pi over 5, 4 pi over 5, which is really as far as I have to go because that's one whole period. Cosine normally starts up at a max, but because it's got a negative, it's going to start at a min. So I'm going to start down here. But because this isn't 1, I have to label that as negative 2. So it starts at a min and ends at a min. Halfway between is the max. And halfway between those 2 points are zeros. Repeat. Starts at a min, ends at a min. Halfway between is a max. Halfway between each point are zeros. So when I connect, oh no, I gotta keep going, my bad. Keep going, there we go. So there's my cosine. Tangent. Okay? Tangent, my period is not 2 pi over b, but pi over b, because that is the original function, original period of the tangent function is pi. Again, I'm going to put my axes. So I have boom and boom. And when we did the tangent function, we went out 2 tick marks and labeled that our period. That was what our period was. And that meant that my asymptote on the tangent function was going to be half of that. Okay? So that means that my asymptote's going to be here because my tangent function straddles it. So each of these blue ones is where I'm going to have my asymptote. Actually, I don't have to do that many. So I'm going to keep going. That makes this one, we have to label the asymptote. So if this is pi over 2, that makes this one pi over 4. This is negative pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. I think that's actually enough. So halfway between is a 0. Halfway between the 0 and the asymptote, I went up 1. And halfway the other way, I went down 1. And then I connected. Okay? Actually, I only had to go that far. And that's what I'm going to do. And keep in mind, if you choose to go only halfway up here, then you have to change that scale. It's only if your tick marks are 1 and negative 1 that you don't have to change that. So you don't have to finish that. I only asked for 2 cycles. Okay? 17, negative 4 times the secant. Secant is 1 over the cosine. So my period is going to be 2 pi over that number of 2. And that, of course, gives me pi. And so let me go put my axes again. So I have boom and okay, that one missed a little bit. All right, so when I graph this, okay, I'm still going to go out 4 tick marks. 1, 2, 3, 4. That's my period. Half is pi over 2. The secant, okay, and what we did from there is we graphed it. So let's go 4 and negative 4 is my amplitude. Secant is 1 over the cosine, and the cosine starts at a max, except for it is flipped, and so it's going to start at a min. And what we did is we went ahead and labeled those points. Okay, starts at a min, ends at a min, halfway between is a max, halfway between those two are zeros. Okay, I'm going to go 4 more tick marks. That's where that period is going to end. And if 4 tick marks is pi, and the next one is 2 pi, and this is going to be 3 pi over 2, just like around our unit circle. That's where my other max is, and those are my zeros. So this is 2 complete cycles here. And so from here, I am going to, wherever I have zeros, I'm going to put asymptotes. So that means that I am here, and here, and here, and here. Okay, if you want to put another one here, you can put another one here. Okay, and then we draw parabolas away from our midline. So this is what your graph looks like. So how many of these do you have to graph to give me 2 cycles? You only have to have 4 parabolas. So if I did 1 right there straddling, then I'm good here. Well, I kind of missed that one. Yeah, let's try that again. All right, so we're here. So you have to label the asymptotes. This is pi over 2. Half that distance is pi over 4. Negative pi over 4. 1 pi over 4. 2 pi over 4. 3 pi over 4. 4 pi over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4. All right, moving on. Cosecant. Okay? Cosecant is 1 over the sine. My period is going to be 2 pi over that b, which is 3. So I'm going to draw my axes. And this time I'm going to go out 4 tick marks and label it 2 pi over 3. So that's 2 pi over 3 1 pi over 3, 3 pi over 3, 4 pi over 3. And I think that's enough. 4 pi over 3. Okay. Cosecant 1 over the sine. Sine starts at 0, ends at 0. That's one period right there. Halfway between is a 0. Halfway between the first two is a max. Halfway between the last two is a min. I'm repeating that. Starts at a 0, ends at a 0. Halfway between is a 0. Halfway between the first two is a max. Halfway between the last two is a min. And just like we did, then I got to go, this is a cosecant. This is 1 over the sine. And since it's 1 over the sine, that means that I'm going to draw asymptotes wherever I have zeros. So these are my zeros, and we've already labeled them. And if I have to have 2 cycles, that means I need to have 4 parabolas. And so always parabolas are going away from your midline. So there's 1, 2, 3. Try to get that point there. And 4. That's what happens when you're in a hurry. Okay, number 19 says y equals -3 times the tangent of pi over 2 theta. Okay, its tangent, my period is pi over pi over 2, which is pi times 2 over pi. So my period is 2. I'm still going to have that same set of axes. I'm using these axes every time until I start shifting things up and down. Okay, so my period is at 2, so on the tangent I go out to that second one and label it as 2, 4, 6. I don't think I need to go that far. But the tangent is the one that we also, on the tangent graph, nope, on the tangent graph, we put the asymptotes halfway of what our period is. So that means that this is where my asymptotes are. And actually that's enough to label. Halfway is a 0 on both of those. Halfway to the right, I'm going up. Except for that it's flipped. It's -3, so halfway to the right, I'm going down. And I have to tell you that that's -3, and this is +3. Okay, if I'm going to go up to that first one. So this makes my graph like this. All right, 20. Sine. What do I have? Sine of theta over minus pi over 2 minus 4. So we've gotten back to my sine graph. My period is 2 pi. This time I'm shifting it down 4 units. So as it's shifting down, I know it's going to be down below. So I'm going to put my axis up here to simplify things. Okay. My period is 2 pi, so I'm going out 4 tick marks. 1, 2, 3, 4. And labeling it, not that. Labeling it 2 pi, pi, 3 pi, 4 pi. That will be my 2 cycles. Okay, if you want to go back that way, make it -pi. Okay, my midline. This is your midline, y'all. So when you take that and go graph it to help simplify things, go down 4. 1, 2, 3, 4. Here's my midline. Okay, I don't have any amplitude changes. Okay, is pi over 2 one of my tick marks? So this is going down. This is going to the right. And pi over 2 is 1 tick mark. So normally my sine graph starts at 0, but I'm going to move it to the right 1 tick mark. Okay? And you can either go, it normally ends at 2 pi, but I'm going to go over 1. And this is when you go back to your key points. Starts at 0, ends at a 0, halfway between is a 0, halfway between the first two is a max, halfway between the last two is a min. And whether you want to copy it that way or copy it this way, I had 4 tick marks was my period. So 1, 2, 3, that's the end of another period. Halfway between is a 0. Halfway between the first two is a max. Halfway between the last two is a min. And I'm going to connect them. Okay, and I've asked you, make sure you put arrows on it because it does continue. Cosine, pi over 3 plus pi over 3 means I'm going to the left. Plus 1 means I'm going up. So when I put my axes on here, I think I can handle staying where we've been, so I'm going to put that there. Okay. My period, actually I'm going to go ahead and graph it. So I put my axes, I'm going to go ahead and put my midline of going up 1. Um, and I'm just going to go by ones here. So here's my midline. Okay. You don't have to label it if it goes by ones. My period is 2 pi, but I have a shift of pi over 3, which is not going to be one of my tick marks if I label it 4 tick marks 2 pi. So I'm going to change it and say that the first one is pi over 3. That's 1 pi over 3, 2 pi over 3. I'll go ahead and do that. So y'all, that's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7, 8, 9 pi over 3. Okay. Um, Now cosine starts up from the midline, up 1. We will go up 1 and down 1 from this midline because our amplitude is 1. So if I start at 1, but I have to go left, pi over 3. So I'm going left. Normally ends at 2 pi, but I'm going left 1. And from there, I'm going to remember halfway between, it's at a min, so I'm right here, which is 1 below the midline. And then halfway between those 2 points are my zeros. And then I continue. So it was 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6. If you want to finish 6 right there, you can do that. Okay? Halfway between those two is my min, and halfway between those are my zeros. So my graph is something like this with your arrows on it. Okay, last two. Yikes. Okay, last two graphs. Y equals negative 2 sine 2 theta minus pi over 6 plus 5. Okay, so I'm going to be moving it up. I think that's the easiest one to deal with. So I'm going to come here and draw my axes. And if I have to move it, okay, this is moving it up. This is my new midline. And I have a stretch of 2. So I've got to be able to go between 7 and 3. Um, this will be easy for you to do tomorrow um, when you take your test. Okay. So my midline 2, 4. Yes, I didn't label that, but let's do that real quick. So I'm going to go 2, 4, 6, 8. Okay. Um, I know that I will go 2 above and 2 below, and that will fit on my graph just fine. My period is 2 pi over 2, which is pi, and I'm shifting it pi over 6 units to the right. So normally I would want it to be 4 units would be 4 tick marks would be my period, but because my phase shift is something different, I'm going to label that at pi over 6. So pi over 6, 1, 2, 3, 4, 5, 6, that's pi. So I know that's going to be the end. That's how long my period's going to be. So am I ready to start? Okay, if that's at pi, that's pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6. Those all reduce again, y'all, except for 5 and 7. So you can go label those accordingly if you want, or do every other one. So the sign starts at 0, okay? Now, it starts at 0, but I have to shift it right 1 tick mark. I've already shifted it up with my midline, so there's my starting point. And we just said it ends at pi, but I'm going to go past 1 tick mark. Halfway between that is going to be 1, 2, 3 tick marks because it was 6 between here and here. That's why it's so important to get that first period down. Get the beginning and the end of your period and then halfway. And what happens halfway between these two? Normally we go up 2, but it says minus, so I'm going to go down 2 to here. And halfway between these two, I'm going to go up 2. Okay? Now, every 3 tick marks is a 0. 1, 2, 3. There's another 0. Halfway between. I'm just following this pattern, y'all. And then here's the other 0. And halfway between those is my max. So, I will be here tomorrow before school. I'll be here during AO. Kind of missed that. Okay? All right. And the last one. All right. Um, Again, I'm looking at it. This tells me I'm moving it down. Okay. Moving it down and I'm stretching it by 3. So when I put my axes, okay. If you haven't had practice, y'all, you just might have to do some erasing. Okay. It's okay. But my graphs on the test are bigger. Yikes. The graphs on the test are bigger, so you have room, plenty of room to do these things. Okay. Um, this is going to shift it to the left. That's shifting it down to, oh, so I'm going to go draw my midline at -2. Okay, so I'm going to have it right here, which means my scale is by ones, so I don't have to do it. This changes my period. The period is 2 pi over 2. All right, that's where that 2 is coming from. And that simplifies to pi. And guess what, y'all? Because my period and my phase shift are exactly the same, I don't have to worry about the phase shift. Because if I go out 4 tick marks, 1, 2, 3, 4, and label that pi, okay, wherever you start, you shift it pi units. Whether you go to the left or the right, you're going to end up at the same place. So that made this phase shift rather harmless. So here's my midline. I started a max, which is 3, which would be up to here. And we already discussed we don't have to go left or right. So there's the first one. My period is pi units, so there's the end of one period. Halfway between is a min. I'm going to go down here to go down 3. So 1, 2, 3. And halfway, excuse me, halfway between those two are my zeros. Continue 4 tick marks to end my period. Halfway between the two is a min. Halfway between the max and the min are my zeros. And remember, that's a max. So when you draw that point at the beginning and end of your sketches, y'all, remember that you need to come back down with it. Oh, that one didn't go very well. Went too far up on that one. So we come back up, okay? Don't make it do that because this is a max on your graph. So when you come back up here, you got to make sure that you curve back around because those are the maxes. Okay? So I hope that helps. If you have any questions, please do not hesitate to email me or come see me before your test. Thank you.